All right, so here's essentially the same problem that you are working on with different numbers. You'll notice that this is essentially the same thing. This has all the parts given with all the solutions. But you have different answers because you'll notice that you'll have different numbers up here. So I'll show you how I get these answers. But first we need to figure out what type of hypothesis test we're going to be completing because we'll be using StatCrunch to do this. Let's look at some of the given information. So notice that that here they're giving you the null hypothesis. This is a right tail test because the null hypothesis is less than or equal to, which means that the alternative hypothesis is greater than. So that tells you it's the right tail test. So we'll address that a little bit later. But also we can tell that these symbols right here, those are the symbols for mean. And so we're doing a mean test, not proportion. And also we're comparing two different samples. So that tells you we're comparing, it tells you in the problem, at least information up here. You don't actually have this information, but it's comparing two population means. And we can tell it's comparing two population means from this null hypothesis, since there's two means and they're being compared. And they're population means. And so let's see what else we have. We have the sample statistics. So we don't have raw data. We have the sample statistics, the sample mean, sample standard deviation, and sample size for the two different samples. And we're also assuming that that the two variances are not equal to, the population variances are not equal to each other. That's what it says right here, not equal. So that tells us that we're not doing a pooled. So we've seen this before. We're not doing pooled. So let's get into StatCrunch. Based on what I've discussed already, we pretty much will be able to figure out everything that we need to do. Exactly what tests we're doing. So we're going to go into stat, and since we do not know the population standard deviation, we're going to be doing a t-stat. Z-stat is when you know population standard deviation, but we do not know population standard deviation. We only know S, which is sample standard deviation, so that's t-stat. And it's two sample, as mentioned. We're comparing two different populations, so we're doing a two sample, as we gathered two samples. And it's not with data, but with summary, because we don't have raw data. So here we go. We can put all the information that's given in this problem. So sample 1 is 2241, and standard deviation is 153, and size is 6, and 2325, and standard deviation is 59, and sample size is 8. So pooled variances is when you know that it's when the population variances are equal, but they're not equal, so we're not checking that. And we want a right tail test, as mentioned, because the null hypothesis is less than or equal to, so the alternative we want greater than, the opposite of less than or equal to. And that's it. Compute. There we go. Okay, so let's see where we get this information. The difference between the sample mean and the two sample means, which we could do pretty easily. 2241 minus 2325 gives us negative 84. And the standardized test statistic is t equals, the t-stat is negative 1.276. So that's all we need from StatCrunch. Well, actually, we can use the p-value. So since this p-value is really large, actually, yeah, so it's not in the rejection region, since our t-stat is not that large, or it's closer to 0 compared to the critical value, which we don't see. But using the p-value approach, we can also tell that t naught, let's see here. Okay, so actually we can use t naught right here. They give us t naught, I didn't notice that. So 1.476 is that is further that's further away from the from 0 compared to our test statistic, which we found. So that tells us that it's not in the rejection region. It's since our test statistic, standardized test statistic, is closer to 0 compared to the critical value, which is right here. So it's not in the rejection region. And so that tells us we failed to reject the null hypothesis. Same sort of decision making that we've done in the past. All right, so let me know if you have any other concerns about this one, and that about wraps it up.